Look at that trend. I'm going to talk about Lambda expressions. My favorite thing is that first line is valid C++ code. That's its own little statement, and I hate it. We'll get into why. So if you've never seen that statement before, I'm going to explain the syntax of lambdas. That's what this talk is about. So Lambda expressions, what are they? Well, there's a few things I could talk about. We could go into lambda calculus, we could go into the Church-Turing thesis, alpha conversion, beta reduction, whole bunch of stuff. List underpinnings of computer science, but no, let's not do that. I can't even speak to most of those topics, and besides, they're going to end up boring. So let's talk about what lambdas really are, like the 80% simplified view. We're talking about anonymous functions that don't have a name. They are more complicated than that. I'm simplifying, but to get the base idea across, you're looking at a function without a name. So this is the syntax of a lambda in C++ 11 and beyond. If you kind of look sideways at it, I like to think it's like a robot or something, or maybe, I don't know, Donkey Kong. Gestalt images, I don't know. Anyway, this blue part, curly braces, these are your function body. This is your function body. Just like a normal function, whatever's wrapped in the curly braces is going to be your function body. I have some code here. I have a print function, takes in the std function, and it just evaluates, it with the ternary operators at true or false and prints true or false. Real simple. I have this right here. Auto is 5 greater than 3, lambda expression. And inside that function body, I have return 5 is greater than 3. I'm using an auto type here because lambdas are a compiler inferred type, so you actually don't know the type of a lambda, so you typically assign it to lambda. And then I'm passing that function here. Think of it like a function pointer if you're kind of used to that. The point is, this function does not get evaluated until I call func parentheses up here on this line. So it's like a deferred execution on there. And this is something stupidly simple. I'm just returning is 5 greater than 3, a function body. Moving on, what are these parentheses when you see a lambda? They are your parameters, just like a function. So in here, I am parameterizing this lambda. I provided an int num on that lambda expression. And then I also allowed my print function to take an int param and I pass that in. So it's a way of me parameterizing my function. Right now, this is pretty much the same exact thing as a normal named function. I just don't have a name for it. So far, we're one-to-one. Where it gets interesting is what are these square brackets? These are the interesting thing. It's a capture list. If you're familiar with closures in other languages like Python or JavaScript, this is the equivalent that C++ has in there. What a capture list does is it allows you it captures the scope of certain variables and pulls them into your lambda. Right here, I have an int target equals 3, and I capture it. At that point, I am making a copy of target and saving it with the lambda. When I go execute this code, even though I've changed target, it still has a copy of 3, so it's going to execute return, what am I using for? And it's 5 greater than 3. I'm missing something. I forgot to parameterize this.
Yeah, you would add the print.
Yeah. Typo. Normally I would have a parameter calling into print, same sort of thing. I just missed the int num up there. But it would return, is 5 greater than 3, or is num greater than 3. Even though target is 6, it can change independent. So I'm capturing the scope of that first variable by value. So there's a few different ways to do capture lists. These are all by value. You explicitly name something, or you just say capture all my local variables by value. Similar thing with references on the right side of that screen. If you capture things by reference, beware. Whatever you capture, its lifetime has to match up with that lambda. If the lambda exceeds the lifetime of your object, you're going to start using deleted or freed memory. So if you allocated something, grabbed a lambda using it captured by reference, and then deleted that entity, and then called the lambda, you're actually calling that lambda on freed memory, undefined behavior. Either everything's going to blow up, or it's going to work for 6 months and then blow up. You want to prefer explicit captures over the default captures. There's an interesting case why you want to do this. Take, for example, this line of code. I have a class, it's, again, stupidly simple, has an int x, and I have a function that returns a lambda, get lambda. And I'm capturing everything by value. And down here, I initialize A, I get the lambda, I delete A, and then I call the lambda. Since I'm capturing by value and not reference, it should all work. But this actually has undefined behavior. The reason is that X isn't an X. It's really this points to X. Because that's what the compiler does when it's going to see local member variables. So it's actually capturing this variable and then putting that in front of the X in front of the lambda. So you're actually going to be doing this on free memory. In C++ 14, you can actually do an init capture, also heard of it as a named capture. Pretty much what you can say is you can say left-hand side equals some expression. It could be a value, it could be a move operation. This is the only way to do move operations with lambdas with C++ 14. And it pretty much gives you a way to avoid that little gotcha. So, but that's C++ 14 and above. C++ 11, you would have had to save off like auto copy equals X and then capture on copy. So why do you want to use lambdas? Dependency injection gets a whole lot easier. You're just passing a function to inject a dependency. I don't have to deal with implicit dependencies littered through my code base. I don't have to create custom classes just to inject one behavior. I forget who said it, might have been John Carmack. Never use a class when a function is just as elegant. I'm paraphrasing, I don't remember the exact quote. But when you just need to inject one single behavior, you can just pass a lambda in and defer the execution to that consumer. Also, if you're used to functional programming styles, this is a step in the right direction. Mapping, filtering, reducing, a lot of things that you can do. Especially when you get to the algorithm library. That's one of my favorite libraries in C++. You can pretty much remove 90% of your loops. Let's say I had this lambda that just said if a MAC address was some special MAC address. Well, in the algorithm library, I can pass that lambda in and say, hey, are any of these MACs that special? And that returns true or false. I can count how many of those are special just by passing in a lambda. I can even replace everything that matches that special MAC address with my own. And the reason this works is because a lot of these functions take a function in as a parameter. Now, I could do a function pointer, I could write a functor object. If you've ever written a functor object, you'll agree with me that lambdas are the way easier way to go on that. You can sort things. So in this case, I'm just doing the lambda inline where I take two IP addresses, get their network byte order, and define a comparison function. If you've used lambdas in any other language, it's the same sort of idea. So if we look back at that.
Can I say my favorite example?
Yes, what is your favorite example?
Qt5. So if you're familiar with the signal and slot mechanism of Qt5, that's how it signals from one thread or one object to another. So in Qt5, you can actually use functors now so previously it would construct these arbitrary string arguments and try to match them up. Instead, you can just use functors and it looks just like, I don't know, doing Android Java programming or JavaScript programming where you can say, on button click, rather than having to define this function that operates on click, you can just have a lambda there and pass it as an argument into the Qt register signal slot mechanism. And it makes GUI programming way, way better.
Yeah, so lambdas are really great for those one-off tasks where you just have to say, okay, on event, go do this one thing. If you got to start using it a whole lot of places, then go with the name function. But if it's a one-off, don't pollute your global namespace or your namespace.
Basically wipes out every use of boost bind. Like if anybody uses boost bind regularly,
or any of the standard binders as well.
Standard bind or any of that stuff.
Bind first, bind second.
So are you all familiar with boost bind? Generally, yeah. So
if you are, go use lambdas and stuff.
Yeah.
If you can.
It's awesome.
Anyway. So in the first slide, I said this was my favorite little C++ statement. What this is, it's a lambda that captures nothing, has no parameters, does nothing, and is immediately evoked, thus doing nothing. So lambda's about nothing. That's all I have. So I'm Pat Viafor. My slides are here. I posted in the Slack channel. I am recording this. I'll put it on YouTube if people want to watch a recording of this as well. Watch me stumble through some slides. Any questions? That's not a question, but I agree. Lambdas are awesome. Thank you, everyone.
Awesome. Well, I think that's all we have for tonight, unless somebody has